All right, this tutorial video is to help you to write the quadratic equation for a graph in vertex form. So we're going to start off by writing the vertex form of the graph, which is f of x is equal to a multiplied by x minus p squared plus q. And remember, f of x is the same as y, and that's going to be a really helpful note for when we solve for a in this problem. So I am going to find the vertex on this graph here, and it looks like the vertex is at 0 over and 3 up. So that's my vertex. It is of the form PQ. So 0 over 3 up. So I'm going to plug that into my equation for P and Q. So I have A multiplied by x subtract P, which is 0 squared plus 3. Now since x minus 0 is just 0, I'm actually going to change it to ax squared plus 3. And now we just need to solve for a. And the way that we're going to do that is pick a point on the graph, and we're going to sub in those coordinates for both x and y. So the coordinate I'm going to choose is this one over here. It is 1 over, it looks like, and 1 up, because we've got 1, 2, 3, and then it looks like this is actually a half, because this scale is different over here. So 1, 1 is going to be our point on the graph that I'm going to choose, and I'm going to plug each of those in for both x and y. Remember that f of x is the same as y. So I'm going to take a 1 and put it over here for f of x, multiplied by a, which we don't know. I'm going to sub in 1 for x squared, and then plus the 3. And now we're going to solve. So 1 is equal to a multiplied by 1 squared, which is just 1, plus 3. Then we've got 1 equals a plus 3. So what I'm actually going to do is move this 3 to the other side by subtracting it. So if I do positive 3, subtract 3, that's going to give me 0. What I do to one side of the equal sign, I have to do to the other side. So I'm going to subtract a 3 over here, and I end up getting negative 2 now is equal to a, since 1 times a is just a. So now I've got my a value, and I can plug that back into my equation to write the final vertex form. So f of x is equal to negative 2 multiplied by x subtract 0, or rather, instead of x subtract 0, I'm just going to leave it as x squared, so negative 2x squared, and then plus my 3. That is my final vertex form. And when I look back at the graph, just to double check, I can see that this is a graph that is a little bit more narrow than the original graph. That's what the 2 is doing, and it's opening downwards, which is what the negative is indicating to me. So that is how you sub in coordinates to help you solve for a, which is the coefficient that's going to determine some of the qualities of this graph.